In this video, I'm going to describe a couple of different ways that we can organize the types of quadrilaterals that we've been discussing and see how they compare to each other. So the first way is that we can draw a family tree. And in your other subjects, you might be familiar with this type of organization. It's kind of like a bubble map or a spiderweb map. We're just going to draw some shapes, describe the information relating to those shapes, and connect them with lines. So at the top of our family tree, it's like the great-grandparents. They're the quadrilaterals. There are two basic properties of all quadrilaterals. The shape is a quadrilateral as long as it's got four sides, and its interior angles, there are four of them, add up to 360 degrees. There are two main types of quadrilaterals. There are trapezoids, and there are parallelograms. So far, we've discussed the left side of this tree. And in a later video, the next video, we're going to describe trapezoids, so the right side of the tree. So let's go down the left side. If quadrilaterals had two kids, they'd have parallelograms and they'd have trapezoids. These kids share their parent properties, but they don't share each other's properties. So trapezoids are not parallelograms, and parallelograms are not trapezoids. Parallelograms are unique in that they have these five properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side angles are supplementary, or consecutive angles are supplementary, and diagonals are bisected, or they cut each other in half. Parallelograms have two kids that inherit their properties as well as their grandparents' properties. The two kids are rectangles and rhombi. Let's talk about the rectangles first. So because rectangles are children of parallelograms and quadrilaterals, they inherit those properties. But in addition, they have two unique properties that make them rectangles rather than just any old quadrilateral or parallelogram. Two properties that make a shape a rectangle are specifically that all angles are congruent, and they are each right angles that measure 90 degrees. And their diagonals are the exact same size. They're congruent. So its sibling is a rhombus. They do not share each other's properties, but they share their parents' properties. So rhombus is also a quadrilateral and a parallelogram. It inherits those top properties. But what makes it uniquely a rhombus rather than anything else is that all sides are congruent. Diagonals intersect perpendicularly. And the diagonals are going to bisect the vertex angles, or those corner angles. So those are the three unique properties of a rhombus. So a rectangle does not have those properties. A rhombus does not have the rectangle properties. But if they were to get together and have a kid, they would have a square, and the square would share all of the properties. So a square has rectangle properties. It has rhombus properties. It also has parallelogram and quadrilateral properties. So it's at the bottom of the tree. It's inheriting all of the properties above it. So we'll ask ourselves some questions like, is a square a rectangle? Well, yeah, a square is a rectangle. It has all the properties of a rectangle. Is a rhombus a square? Well, we can't say that because a square has rectangle properties that a rhombus does not share. So we can't say that a rhombus is a square. But we could say a square is a rhombus because a square has all of the rhombus properties. So some tricky questions that you can answer like that, and you have some practice problems to do that with. Let's talk about the right side of our quadrilateral family tree, the trapezoids. Trapezoids have one main quality, and that is that they have one pair of opposite sides. So these sides are not parallel. So it has its quadrilateral properties and this additional property. If we get more specific and talk about a certain type of trapezoid, an isosceles trapezoid is a specific type. There are others. But in an isosceles trapezoid, it has this property. It has one pair of parallel sides. In addition to that, it has these two properties, and these are actually the properties of an isosceles triangle, which is an isosceles trapezoid with the top cut off. So of course it's going to inherit those isosceles triangle properties. So there's our family tree of quadrilaterals. As we move down the family tree, these shapes are inheriting all of the properties of those above it and those properties that they're connected to. So there's one way that we can organize this information. There's a second way that we can do it. We can use a Venn diagram. Sorry, it's a little sideways here. A Venn diagram does not necessarily have to only involve circles. We can really create an organizational tool by having any intersecting shapes. So if the shapes overlap, they're going to share properties. If they don't, they're not going to share properties. So everything on this page is a quadrilateral, every shape that I write down. And the quadrilaterals are specifically going to hang out on the outside here. But as I work inside, these shapes are going to also be quadrilaterals. So we have quadrilaterals, just generic quadrilaterals, and we also have trapezoids and isosceles trapezoids, as well as other types of trapezoids. So those are the quadrilaterals. Then if we be more specific, types of quadrilaterals could also include parallelograms. So these parallelograms are inside the quadrilateral big rectangle, so they're going to inherit the quadrilateral properties. But just things that are inside the smaller rectangle are parallelograms. So notice that the trapezoids are not inside the parallelogram box because they're not parallelograms. They're just quadrilaterals. So parallelograms have these 5 special properties. If we get more specific with types of parallelograms, they're going to be inside this rectangle. So rectangles are parallelograms. We'll call the rectangles the left circle here. Things that are in this circle are rectangles. On the right circle, we could talk about rhombi. So things that are in that circle contain the rhombus properties. And inside the very center are squares. They're going to inherit every property that we're talking about with regard to quadrilateral and parallelograms. And notice that the squares are in the rectangle circle. That's because squares are rectangles. Also notice that squares are in the rhombi circle because squares are rhombi. But rhombi are not squares, so we can't have them in the center. And likewise, rectangles are not squares, so they can't be in that circle, that middle part of our circle. So overlapping shapes share properties. Those things that are not overlapping or inside are not sharing those properties. So another organizational tool that we can use to organize these properties in these types of shapes. So hopefully one of those, if not both of them, will help you answer the practice problems, talking about comparing these types of shapes and their properties.